Okay, hello to everyone. This time I'm going to discuss to you the analysis of variance. This is another inferential statistical tool. Okay, so let us discuss this topic, which is analysis of variance or ANOVA. Okay, the other term for ANOVA is F-test or analysis of variance or F-test. It is used to test whether there is statistically significant difference between three or more groups or treatments. So you can only use analysis of variance if there are three or more treatments. Okay, if there are only two treatments, you can use the t-test. Okay, always remember that there should be three or more groups or treatments. It may be one-way or two-way ANOVA. Okay, when we say one-way ANOVA, you will only compute for one variable. Okay, for two-way ANOVA, you are going to compute two or more variables. For example, if you will compute only the height, then you will compute the effect of fertilizers on the height. Then if you want to test whether fertilizer and type of soil can affect the height of the plant, then you will use two-way ANOVA. Okay, so that is how you are going to use the one-way and two-way ANOVA. For one-way, there is only one variable involved. For two-way ANOVA, you will use two variables that are involved. It can be used to test in CRD and RCBD design. So if you use CRD and RCBD design, you will use this one-way ANOVA. Okay? The formula for the analysis of variance is F stat equals to MSBG divided by MSWG. Wherein F means factor. Ang ibig sabihin ng MSBG ay mean square between group, and MSWG means mean square within group. So that is the meaning of MSBG and MSWG. Okay, next is, okay, we have here a sample problem. Suppose a researcher wants to test if there is significant difference on the effect of treatments to the height of corn plants after 1 month at 0.05 level of significance. Okay, suppose the researcher uses three treatments. Okay, treatment 1, treatment 2, and treatment 3. Suppose, for example, she used cow manure, horse manure, carabao manure. And then, of course, there are three replications. Always three replications for each treatment. You can use more than three, but the minimum is three. Okay? So for treatment 1, the height of the plant in inches after 1 month is 10 inches. So this one is the score for T1R1 or treatment 1 replication 1. For treatment 2 replication 1, we have 9 inches. For treatment 3 replication 1 or T3R1 is 9.5. So these are the sample scores for each treatment from treatment 1 to replication 3. Then treatment 2 to replication 3 and treatment 3 replication 3 or T3R3. So these are the scores. So this is how you are going to arrange or to put your data in when you are going to compute the analysis of variance. Okay, so those are the data. Then we have here the steps on how you are going to compute. First, you are going to give your null hypothesis and alternative hypothesis. Okay, for our null hypothesis, the three treatments has no significant difference. For alternative hypothesis, the three treatments has significant difference. Okay, now to check which one is the correct hypothesis, you have to follow this rule. If the computed F stat is higher than the tabulated F, reject the null hypothesis. So meaning to say, if the computed F stat later on is higher than the F in the table, you have to reject the null hypothesis. If it is lower than if it is lower, then you have to accept the null hypothesis. Okay. The next is the step 2, you compute the mean. Okay, how are you going to compute the mean? First, you have to get the total. 10 plus 11 plus 11.5 is 32.5. Okay, 9 plus 9.5 plus 10 equals 28.5. 9.5 plus 10 plus 10.5 equals to 30. To get the mean, you divide the total with the number of replications. So there are 3 replications only, no? So 32.5 divided by 3 equals 10.83. 28.5 divided by 5.3 equals 9.5. And 30 divided by 3 equals to 10. So this is the mean. Okay, number 3 step. compute the sum of squares. Okay, to compute the sum of squares, first you have to get the square of each height of each treatment. For example, for x sub 1, which is the treatment 1, 10 times 10 equals to 100. 11 times 11 is 121. 11.5 times 11.5 is 132.25. Okay, you will do the same for treatment 2. 9 times 2 equals 9 times 9 equals 81. 9.5 times 9.5 is 80.8025. 10 times 10 is 100. Okay, you will do the same for treatment 3. Then after that, you get the total. The total of 10 plus 11.5 is 32.5. For the sum of square, 100 plus 121 is plus 132 equals 353.25. Okay, so you will do the same for uh, treatment 2 and treatment 3. Okay, so we have here some of the letters to be used in your formula. For the small k, this is the number of treatments. There are only 3 treatments, treatment 1, 2, and 3. For n is the number of replications. There are 3 replications, replication 1, 2, and 3. For capital N, we have 9, the total number of replications. Since there are 3 replications for every treatment, 3 for treatment 1, 3 for treatment 2, and 3 for treatment 3, then the total of replication are 9. Then G is the total, grand total of all the scores. So if you are going to get the total of all the scores, which is 32.5 plus 28.5 plus 30 equals to 90.5. Then 3x squared is the total of all sum squares. You get the total 353 plus 271.25 plus 300.5 equals to 900 something. Okay, you just add the 3 sum of squares to get the total of sum squares. Okay, the step number 3 is compute the sum of squares. So the sum of squares equals to, for treatment 1, this is only for treatment 1, the sum of x sub 1 square minus x sub 1 parenthesis square divided by the number of replications. So the sum of x sub 1 square is this one, 353.25 minus x sub 1 equals to 32.5. Oh, that is x sub 1, 32.5 squared divided by 3. N is the number of replication. There are 3 replications, that's y equals to 3. Okay, 32.5 times 32.5 equals 1056.25 divided by 3 equals to 352.08. Okay, so 353.25 minus 352.08 equals to 1.17. This is the sum of square for treatment 1. Okay, you will get also the sum of square for treatment 2 and treatment 3. And these are the computation. For sum of square for treatment 2 is 271.25. Where did we get this one? Okay, it was taken from this one. Okay, you can go back to that table. 271.25 minus the number of total for treatment 2 is 28.5 squared divided by 3. 28.5 times 28.5 is 812.25 divided by 3 equals 270.75. So you can now subtract 271.25 minus 270.75 equals to 0.5. Okay, similarly with the sum of square for treatment 3. Okay, this is the treatment 3. We have 300.5 and the total is 30. So 300.5 minus 30 squared. 30 squared, 30 times 30 equals to 900. Divided by 3 equals to 300. 300.5 minus 300 equals 0.5. So that is the sum of square for treatment 3. Okay, next is the step 3. We have to compute the sum of squares. How are you going to compute the SS or sum of squares? Okay, we have here the ANOVA table. You have to have this table. Sources between group, and SS sources total. Okay, sum of square, degree of freedom, mean of square, and F stat. Okay, to get the SS total, how did we get 14.97? The formula for SS total is, okay, the sum of x squared minus g2 divided by n. Okay, you can refer to the previous step. You get all the total of x squared, x sub 1 squared plus x sub 2 squared plus x sub 3 squared, which is 353.25 plus 271.25 plus 300.5 minus ang g natin is 90.5 squared. Okay, so 90.5 times 90.5 equals 8,190.25 divided by ang n natin yung number ng total number ng replication. So 3 bawat isa kaya equals to 9. Okay, 8,190.25 divided by 9 equals to 910.03. Paano nakuha yung 925? You add 3.53.25 plus 271 plus 300.5 equals 925 minus 8190.95 divided by 9 equals 910.03. You subtract, the answer is 14.97. Okay, that's why the SS total is 14.97. You write it here in the table. Okay, you have to complete the table as stated in step 3. Okay, how are we going to get the within group and SS for between group? Okay, to compute the SS for within group, you add SS sum of square for treatment 1, treatment 2, and treatment 3. 1.17 plus 0.5 plus 0.5. Okay, nakuha ito doon sa kinompute nyo sa step 2 or step 1. You add this 3, you will get 2.17. Okay, that's why this is 2.17. For SSBG, you have to get the total of SS total, which is 14.97, and you subtract SSWG. Okay, 14.97 minus SSWG is 2.17. Okay, you subtract, the answer is 12.8. Okay, so that is how you are going to get the SS or sum of squares between group, within group, and total. Next is compute the degree of freedom. How are you going to get the DF? Okay, how did we get 8, 6, and 2 here? To get this 8, you have to, the formula for degree of freedom total is capital N minus 1. The capital N is the number of replications, which is equal to 9. 9 minus 1 is equals to 8. Okay, always 1. This is always equals to 1. So 9 minus 1 equals to 8. Then for the degree of freedom for WG within group, we have the capital N minus small k. Capital N is the number of total number of replications, which is equals to 9. K is the number of treatments, wherein there are 3 treatments. So 9 minus 3 equals to 6. That's why this is equals to 6. For the degree of freedom for between group BG, how did we get 2 here? Okay, the formula is K minus 1. K is the number of replications. There are only 3 replications. Okay, so 3 minus 1 equals to 2. That's why this is equals to 2. Okay, so this is the how to compute the degree of freedom. Okay, next is compute the mean of squares. How are you going to compute the MS? Okay, how did we compute this one? To compute this one, MSBG, the formula is SSBG divided by DFBG. You divide this 2. 12.8 divided by 2 equals to 6.64. Okay? To compute MSWG, you divide SSWG divided by the DF, which is equals to 6. So 2.17 divided by 6 is equals to 0.3617. Okay, you write the answer here. There's no need to get the total here. Okay, next is step number 6. To get the step number 6, you can now compute the F-stat. So this is now the computation for the ANOVA or F-stat. What you are going to do is to divide MSBG with MSWG, wherein the MSBG is ilan? We have 6.64 and the MSWG is 0.3617. So that is the given. So 6.4 divided by 0.3617 equals to 17.69. So that is your F stat or the computed F. So ito na yung F natin. Okay, next is, okay, you are going to compare the F stat with the tabulated F or F tab from the table using alpha level of significance equals to 0.05. Okay, so we have here the degree of freedom between group is 2 and the degree of freedom within group is 8. So you are going to use the degree of freedom between and the degree of freedom within group. Okay, the degree of freedom between group BG is 2. Okay, is it really 2? Okay, we have degree of freedom 2 and the degree of freedom within is 6. It should not be 8, it should be 6. Okay, the degree of freedom within group is 6. So 2 and 6 is, this should be 6. Okay, the degree of freedom between is 2 and the degree of within is 6. So 6 and 2, okay, they meet here, which is 5.114. 143, 5.143. So the degree of freedom is 2 and the degree of freedom within group is 6. This is 6. Then the tabulated F is 5 point, okay, they meet at 5.143. So this is 5.143. Okay, so let us compare which one is higher and which is lower. Okay, so according to the rule, if the computed F stat is higher than the tabulated F tab, reject the null hypothesis. Okay, since the computed F stat is 17, so it's very, very high. Okay, 17.69 is higher than F tab, which is 5.143. We have to reject the null hypothesis. Okay, we really have to reject because it's very high. 17.69 is higher than 5.143. We have to reject the null hypothesis and accept the alternative hypothesis. So meaning, this means that there is a significant difference in the effect of different treatments to the height of corn plants. So each treatment has its significant difference, meaning to say they are different from one another. Therefore, further tests are needed to identify which treatments are different and which are almost the same. So though we said that there is significant difference, maybe one or two of the treatments are the same and then the other might be different. So to be able to know whether which one is different and which one is the same, you have to use further tests. Okay, you will use other tests like maybe Tukey's or Sheffey's test, the post hoc test. Okay, which is can be done using a computer software. Okay, so kailangan mo na ng computer software to compute the further test. Okay, to identify which treatment are the same and which treatment are different. So that is your conclusion. Okay, so we have here your performance number 3. Compute the F-test or one-way ANOVA of the study given the data below. So we have here the data. You are going to compute the F-test. Effect of different amount of fertilizers to the weight of pechay plant after 1 month. So this one is the weight. Okay. We have the treatment 1, treatment 2, and treatment 3, and the replications. So you are going to get the F-test or one-way ANOVA. Okay, to be submitted at the end of the quarter. So that's it. If you have any questions, you can text or chat me. Okay. Thank you and good day to everyone.